Good morning. Good afternoon to all of you. Um, can you hear my voice? Please respond any of the participants. Can you hear me? Please respond.
Good afternoon, sir.
Good afternoon. Thanks for the response. So welcome to this course of remote sensing and GIS using Google Earth Engine. I'm your trainer Sukant Jain, and I will be there with you for the next 4 sessions. That is today, tomorrow, next Saturday, and next Sunday. And in these sessions, we are going to discuss about Google Earth Engine and how you can apply your remote sensing and GIS techniques using Google Earth Engine platform. Okay, so before the beginning, I just want to take a quick introduction of you and me. So first of all, I will start by myself. That my name is Sukant Jain, and I'm working as a research scientist in National Institute of Hydrology, Bhopal. I've done my graduation in civil engineering and post-graduation in remote sensing and GIS from Indian Institute of Remote Sensing, Dehradun. I have more than 7 years of experience in working in state and national government level of organization in India, in which I have learned a lot about various software tools and datasets, specifically in hydrological and geospatial application. And in this session, I'm going to discuss about discuss about the Google Earth. Okay, so this is from my side.
Okay.
So I request all the participants to introduce themselves. And please, Mr. Chutosh, you can start.
Okay, sir. First of all, good afternoon. My name is Ashutosh Umare. I am a graduate in agriculture engineering, and I am from Ratnagiri, and currently working in Mitra Agro Equipment Nashik as a product development and marketing research engineer.
So do you have any background of remote sensing in GIS, a little bit, or how much you know about the remote sensing in GIS?
So I have the basic knowledge of Google Earth.
Okay.
I have done a master market research project in our company.
Okay.
How to find the orchard crop for the new pockets,
Okay.
finding the new pockets.
Okay. So I think you don't have very much of idea about basic remote sensing in GIS, but you have
No.
okay. So what is your purpose of joining this course?
I want to get an basic overview of Google Earth Engine.
Okay. And next is, I think, Miss Darvinia. Please put on your unmute your mic and introduce yourself.
Hello.
Hello. Hi.
Good afternoon, myself Darvinia. Okay, I have completed my master's in remote sensing and GIS with geography, and now I have completed my master's in 2020, and now I'm working as an like a teacher in a college.
Okay.
So I have joined this course to get some further knowledge about remote sensing with Google Earth Engine. So I have joined the course.
Okay. So I think you have very much about you know very much about remote sensing in GIS.
Yeah, I have done my master's in GIS and remote sensing.
Okay. So before beginning the course, like one of the participants had said that he has a little bit of knowledge of remote sensing and GIS. So just for the quickly, I'm going to start with the presentation, with a small presentation of Google Earth Engine. But before that, I'm going to show you one or two slides of the remote sensing and GIS. So what basically is remote sensing and GIS, and how this spatial data set can be utilized in your particular domain. And after that, we are going to start with the Google Earth Engine. So can you see my screen?
Yes, sir.
Okay. So this is just a brief introduction that what is the geospatial technologies and what is the remote sensing and GIS. So when we talk about the term geospatial tool, so that terms combined of the three terminology, that is remote sensing, GIS and GPS. Okay. Okay. So what is actually the geospatial technologies refers to all the technology used to acquire, manipulate, store and geographical information. And it is the combination of remote sensing, GIS, that is geographical information system, and GPS. And each technology has a different use when we are using partially. So what is basically actually remote sensing? So in the terms, it is you can get from the term that remote sensing means sensing anything from the remote area. If you want to sense anything from far behind that point, from a remaining remote area, so that term is known as remote sensing. Remote sensing is the art, science, and technology of for observing any object or scene or phenomena by instrument-based techniques. Remote means because the observation is done at a distance without being physical contact with object or particular, like if you are standing far from any object and you can hear about that object, so that is particular nothing but the remote sensing. Sensing means detection of energy such as light or another form of electromagnetic energy. That can be, and that energy can be sound waves or electromagnetic, or we can say radar waves or any other electromagnetic waves that we are using sensing. Okay, so how does this remote sensing process work? So first of all, when we say sun is the ultimate source of energy, which is enlightening the Earth's surface. So when sun emits some energy, that means the energy source of illumination, it penetrates the clouds or any atmospheric conditions or any atmospheric setup and it goes to the surface of Earth, that is, it interact with the target, and that target can be building, trees, or any other barren area, maybe land surface area, maybe water body. So that is the object 3, that is the target. So after the sunlight hitting the target, that target will automatically emit some of energy, which is observed by the sensor D. The D sensor will observe that yes, this particular object has emitted the green light. So that means it can be the tree. This particular object has maybe emit the blue light. So that can be seen as object as water body or another water body. So that can be detected by sensor. So after the sensor receives the energy transmitted by the target, it will goes to the station's location, the Earth's surface, that is known as the processing station. So transmission, reception, and processing of this transmitted energy will be done, and on that particular analysis, on that particular data, the data can be transformed into information through analysis purpose, and with the help of that analysis, we create our application in varieties of field. The simplest example, if I want to say, if you have opened any time of Google Earth, like I think everybody has opened the Google Earth. In Google Earth, then in Google Earth we can easily visualize the water body. So how actually we visualizing water body? Because sun is emitting some of energy to the water bodies, and water body being the we know the spectral profile of the water body is that it emits the larger amount of radiation in blue band. So the sensor receives some of the information in the high in the blue band, and that information is sent to the processing station. And with the help of some analysis tool, software, and some knowledge, we can access that yes, this particular thing is nothing but the water body. And this is the whole idea and process of remote sensing. So if you're working in the agriculture field, if you want to identify the particular area is agriculture field or not. So we know that the agriculture means the vegetation reflect more in the near infrared band. So if the particular thing is interacting more in near infrared band, then we can say that particular thing can be the vegetation or agriculture area. So the remote sensing platform, it is not necessary that it has to be the satellite based. It can be the airplane based, like drone. Like in the present scenario, drone based service is actually in demand, but it is an expensive technique, and it is not necessary that it has to be some flying mode. It can be also ground based, like terrestrial laser scanner or total illusion. What it does, it emits the laser which goes to farthest point, like 1 or 2 kilometers, and can detect the profile of that particular surface. So what is the physics behind the remote sensing? The remote sensing relies on the measurement of electromagnetic waves. The most important source of electromagnetic energy is the sun. Some sensors detect energy emitted by the Earth itself or provide their own energy, example, radar. So when we talk about the electromagnetic spectrum, so this is the window of electromagnetic spectrum. So we particularly know that we have come up with this type of electromagnetic wave, that is X-ray, ultraviolet rays. Then we have also encountered with the radio waves. So this is particular electromagnetic range, that is from 0.4 micrometer to the 0.7 micrometer is visible range. Like the human eye can detect the rays which are falling only in this particular band. But when we talk about the remote sensing, not only the visible range, but the reflective infrared, thermal infrared, and microwave is also helping us to image this Earth's surface. The electromagnetic spectrum ranges from shorter wavelength to the longer wavelength, which includes microwave and broadcast radio waves. There are several regions of the electromagnetic spectrum which are useful for remote sensing. As I told you, that the visible, reflective, and thermal infrared. Like I think everybody has heard about the night vision camera. So what actually night vision camera do? Night vision camera actually capture the image in infrared sensors. So what does infrared sensor do? It emits the light in night also, but human cannot detect this infrared because human are only prone to visible light, only prone to watch or detect this visible range of band. But when we talk about the sensor, various instrument, various cameras that can detect some varieties of range of this particular spectrum. So what are the particular advantages of remote sensing? That why do we use the remote sensing? First of all, it is a global coverage. Like you don't need to rely on like physical contact is not necessary. So you can access the imagery of any part of this world. The synoptic view, synoptic means the view from above. So we know that in any type of plan view or in any type of planning, the synoptic view or the view from above is get very much detailed. Then repeatability, like we can access the satellite data or any type of data on a very repetitive mode, like daily, 15 daily, 13 daily, or sorry, 50, maybe in a sub daily also. And of course, if the physical contact is not required, it is also cost effective solution. Now, what is the imaging from the space provide? Actually, it provides the near real-time data. Like if you want to get the information, like the flood happens and the satellite passes over that particular area after that particular flood happened, then we can get the data in near real time. Then we can get the temporal information, like various rainfall products are available in like 3 hours or 30 minutes data. Spatial information, like we can detect even a car with the help of remote sensing techniques like 1 meter spatial resolution, and we can get the synoptic coverage like in a single scene. The 25 to 800 kilometer of surface area of Earth can be detected, and then we can access of the topographic data also. Now, next thing is GIS. So what is actually basic the GIS is? So GIS is nothing. GIS is a computer system capable of assembling, storing, manipulating, displaying, and geographical reference information. So what is actually geographical reference information? So we have learned about the telephone directory. We have in the childhood we have seen the telephone directory. So telephone directory has two things. That is, one is phone number and another is name. But that data doesn't incorporate the location of that particular user or particular phone number. So if we incorporate the location, that is either address or the geographical location, that is latitude or longitude, so that data will become the GIS data, that is geographical information, because we have included the geographical reference information in particular data set. A GIS is an organized collection of computer, hardware, software, geographical data, personnel to efficiently capture, store, update, manipulate, analyze, and display all form of geographical reference information. So the perfect example of this particular data set is we have used the we have encountered in the COVID-19 time, like if we want to identify the particular orange zone or green zone. So how do we identify? We get the data of how the infected person are increasing in particular location. So with the help of that particular geographical information of that particular data, we will able to capture that this area is more prone to the infectious disease. So with the help of some software, data, and some personnel using those data, we can analyze that yes, this area is of danger zone. This area should be declared as the red zone or green zone. So what are the various components of this GIS data sets? The GIS, that is Geographical Information System, is a network which to connect all of these other segments of the GIS. Then we have hardware like computer and mobile is the component. Then software like web browser, Google Earth, ArcGIS is our software in which we analyze our data. The database, the procedure like the how do we analyze the data set, and of course the people like the user and the developer are the components of this GIS. So in the GIS, when we talk about GIS, there are particular two type of data sets, that is vector and the raster. The difference between the vector and the raster is this: vector includes the data set which combination of line, points, and polygon. Anything in the earth on the earth surface can be represented either by line, point, or polygon. Then we can say that that particular data set is vector data set. But if the data set is captured with a form of pixels, pixels is nothing but the image. Like if we take an image from our mobile phone and we zoom into a certain extent level, we will see that the image is nothing but the formation of pixels. So if the data set is made up of pixels, we can say that it is a raster data set. And not only the spatial data set includes the visualization, but in the back end, that vector data set can be included with some type of the attribute data, like particular the name of this line, name of this polygon, or the area of this particular polygon or line, etc. So now the third point is GPS. So I think everybody knows about the GPS. I think everybody has done something directly or indirectly with the mobile. So GPS is nothing but to capture the location in particular reference system in the Earth surface is known as the GPS. So this is particular a basic introduction for those who don't know anything about the remote sensing and GIS. That what is the remote sensing and what is the GIS, and how we can incorporate this technique, that is remote sensing and GIS, in our day-to-day or particular application. Now, I'm going to discuss more about how the Google Earth Engine will solve your problem in analyzing in the analysis part of this remote sensing and GIS techniques. Okay. So up till now, do you have any problem like Mr. Sorry.
Ashutosh, sir.
Mr. Ashutosh. So it is my recommendation to you that after completing this course, either today or tomorrow or whenever you require, you please go to some basic definitions of what is actually remote sensing and what is the GIS. Because this course is not actually about the basic of remote sensing and GIS, but if you learn about some basics, more basics of remote sensing and GIS, you will definitely learn more about how you can do this computation analysis using this particular Google Earth Engine. Okay.
Okay, sir.
So if you are arriving any type of question during this lecture or during any time of this training exercises, you can write down in the comment section. I will try definitely to answer that particular question, whether it is related to remote sensing, whether it is related to basics of remote sensing in GIS, or some advanced question related to Google Earth Engine. So feel free to ask anything. Okay.
Okay, sir.
Okay. So now the introduction to Google Earth Engine. So basically we have already heard about the Google Earth, but we haven't heard more about the Google Earth Engine. So there is a difference between the Google Earth and the Google Earth Engine. Google Earth is nothing but Google Earth is nothing but the 3D globe visualization, and Google Earth Engine is the geospatial analysis tool. Okay, so please pardon for 1 minute. Okay, so there is a basically difference between the Google Earth and the Google Earth Engine. So as I said, the Google Earth is nothing but the 3D globe visualization. With the help of Google Earth, you can only visualize this particular satellite imagery, historical images, etc. But with the help of Google Earth Engine, you will be able to analyze those geospatial data sets. So Google Earth and Google Earth Engine are two separate technologies focused on solving the separate problems. Google Earth is a rich 3D based map on which raster and vector data can be overlaid on. But in the Google Earth Engine, it enables the processing of massive amounts of raster and vector data. So this is the basic difference between the Google Earth and the Google Earth Engine. So what is actually the problem in which we can say that the Google Earth becomes a more prominent things in analyzing the particular geospatial analysis. So this is a typical geospatial analysis workflow. So when we analyze some geospatial data sets, so how do we do that? First of all, we will first acquire the data sets. We first of all select our data set, then we download the data and we download the particular metadata. Like if you want to do the analysis on some Landsat data, Landsat is nothing but a satellite data owned by US. So first of all, we will identify, yes, this particular date of satellite image is useful for us to detect any particular analysis. Then we download those data set and we note that a single tile of Landsat data required approximately 1 GB of data sets memory. Then we will also download or we also acquire the metadata of that particular scene, like the date, the time of acquisition, the particular bands of that particular data, so that we can analyze more prominently. And after the acquisition, what we will do, we will prepare the data according to our own need. Like if there is a missing data sets, we will first of all identify the missing data sets and perform some necessary actions in order to fulfill that particular missing data set. Then we will perform some necessary correction like cloud masking, shadow correction, atmospheric and topographic correction. And at the end of that particular preparation, we will try to convert that particular data into the required format. If we want to suppose do any modeling work, or we want to harness that particular GIS data into a what we can say hydrological model or agricultural model or any other software, then we have to convert our data set in particular required format. And after doing so, we will analyze our data. That means we are converting that data into our required information. So this is a typical geospatial analysis workflow. If you want to work any type of geospatial data set, if you want to analyze any type of geospatial techniques, these are this particular workflow. So the time and the resources are required in this completing these two steps is very high. That means approximately 80 to 85% of your time resources are going to utilize in doing these two tasks, and rest of the 20% are depending on the user ability to convert that data into information. So what does this Earth Engine do? It will enhances your these two steps and reduces your efforts of this 80% to very much less amount. Like if you have created some of the typical script or tool in creating data acquisition and data preparation, you don't need to perform these two tasks again and again repeatedly. You just directly need to focus on this analysis part. So this is the problem which were arising before the Google Earth Engine era, but now with the help of Google Earth Engine, you will be able to solve these two tasks immediately and more efficiently. So what is actually basically Google Earth Engine? So Google Earth Engine combines the multi-petabyte catalog of satellite image and geospatial datasets with planetary scale analysis capability and make it available to scientists, researchers, and developers to detect changes, map trends, quantify differences on Earth's surface. As we have highlighted the important keywords in the red map, like it is a multi-petabyte catalog, like means it has numerous number of data sets with combination of satellite imagery and geospatial data sets. And it is freely available for scientists, researchers, and any number of users to detect any type of changes, map trends, quantify differences on the Earth surface. The satellite images are there. You just develop your own algorithm and you can get the particular your real world application. So in the simple terms, what is Earth Engine? Earth Engine is nothing but it is the archive of remote sensing with petabyte data in one location, and it is a cloud-based geospatial processing platform for executing large-scale dataset and analysis. So why we should say that the Google Earth Engine is a powerful software? Because it has a public data catalog. Like means most of the freely available data sets are available in the Google Earth Engine. It has a vast amount of publicly available data sets, and you don't need to store data into your particular PC or system. It has a very high processing power like computation engine. It is a very good interactive development platform, and with the help of Google Earth Engine, you can save and share your work routine on the daily basis analysis. So why you should use Google Earth Engine? So first of all, it is a planetary scale science. So you don't need to stick only on particular area. Like if you're working on a particular state or particular city of India. So, but with the help of Google Earth Engine, you can apply the same technique, the same analysis all over the planet, any area of this particular world. So it is not only stick to a particular location, but it is a planetary scale science. Second, it is a free cloud processing with built-in function. So the main thing, it is freely available. So you don't need to pay anything to the Google Earth Engine developer to create your own tools or any projects. And with the help of Google Earth Engine, it will allow you to use their built-in functions, which is already available in the Earth Engine. Thirdly, it has massive amount of online particular public data set like all the Landsat, MODIS, Sentinel, and varieties of atmospheric land surface data available freely in the Google Earth Engine. Fourthly, you are not only restricted to use only the available data set, but you can also utilize your own data set after ingesting that particular data set into the Google Earth Engine. Lastly, it has a very flexible access with the help of JavaScript and Python programming language. So these are some data set or some example of the Earth Engine public data set like we have entire Landsat series of Landsat 4, 5, 7, 8, and not only the raw data set, but top of Smartferic and surface reflectance data set also. Then we have MODIS data set, like a MODIS product of daily, 8 daily, 16 daily of NDVI, LST product are also available there. Then we have varieties of terrain data like SRTM, G2CO. Then we have varieties of land cover data like globe cover, NLCD, and atmospheric and rainfall data also. Presently, the Google Earth Engine has more than 200 public data sets, and every day it is keep on updating. Like Landsat has passed over your particular surface area maybe 3 days back, so it will automatically ingest it in the Google Earth on the regular basis. It has more than 5 millions of images, and it has particularly more than 5 to 6 petabytes of data, which is keep on updating. So this are the components of the Earth Engine. Like if you are going to use the JavaScript API, so these are the particular component we will more discuss about in the practical session. Like this is the map area, this is the layer panel, and this is the code editor in which we write. So we will talk more about in the next session. So what is the actually API? API is nothing but a bridge between connecting two type of program. API full form is application program interface. So Google Earth Engine allow you to interact with the dataset using JavaScript and Python API. So every JavaScript and Python API has certain advantages and disadvantages over this. So presently in this training, we are going to cover the JavaScript API. It has a very rich documentation and tutorials. It is easy to get started. That means you are a beginner to Google Earth Engine. JavaScript is very friendly to you. It has a very built-in interactive mapping and functionality. It is made up of built-in authentication. You can create your Earth Engine apps, but it has a disadvantage is that it cannot install the additional package. But on the other hand, the Python API has more numerous number of packages, but it has a very limited documentation, and there are some disadvantages like sharing the what we can say data sets or the codes is very much easy in the JavaScript, but not very much easy in the Python API. So basically, how this Earth Engine works. So you first of all get an image. So in order to get an image, either you can use some projection, resolution, you can extract some band, bounding box, and some visualizing techniques. After getting an image, you can apply your own algorithm like NDVI, NDWI, or you can do, if you want to mask the particular image, you can apply a simple algorithm that are available in the Earth Engine. And if you want to do this particular task over entire series, you can do either by filtering some series, like if you like there are n number of Landsat data sets. If you want to do the particular task in only 5 to 6 data set, you can filter your collection, and you can apply those algorithm in all those particular collection without downloading and using your local computational power. You can reduce the collection and create a good mosaics and good reducer data sets. And you can create an particular output either in the map format like this or in the graphical or tabular format. And then you can lastly perform some vector operations if you want to conclude your data sets more prominently. So these are some case studies how the Google Earth Engine can be utilized in solving day-to-day remote sensing and GIS problems. Like this is an example of large data set processing with just few lines of code. So in this chart, I have described, I've given the rainfall, the long-term annual rainfall of Madhya Pradesh from 81 to 2020. So in order to analyze this type of data sets, traditionally, what we will do, we will actually gather the data sets of each and every station location of Madhya Pradesh. Then we will do the interpolation, and then we will do the daily data to monthly data, and we will accumulate that particular data on the annual basis. But with the help of Google Earth Engine, in which just few lines of code, like 6 to 7 lines of code, we can create this type of chart and graphs either in the region MP or whole over India or a particular state or particular region. So we can do with just few lines of code. Another example is that you have heard about the NDWI or NDVI. So in order to perform NDVI or NDWI, what actually basically do, we particularly download the Landsat or any other multispectral data set. Then we apply the algorithm like green band minus NIR upon green plus NIR. Then we will get the NDVI, NDWI or NDVI. So in order to do so, you first have to download the data set, then you have to apply the algorithm. So what if you require to do this particular task on a very big area like whole over India? So what you will do, you will download each and every tiles which constitute more than 1,000 tiles, and you will apply those algorithms over 1,000 tiles. So it will require huge amount of computation, huge amount of data sets, huge amount of time. But with the help of Google Earth Engine and with just few lines of code, you can calculate the NDVI or NDWI of whole over region of larger data set with just few clicks. And with the same thing, you can calculate the varieties of differential indices like MNDWI, WRI, NDDVI, or any other what we can say indices. You have to just change some little bit formula and you can get this formula. So in this training, we are going to do this particular task and get how to particularly calculate the NDVI or various indices with just few lines of code. And not only that, you can do some advanced tasks in the help of the Google Earth Engine. Like when we talk about the rainfall runoff modeling, so what we are totally depend on the some software and tools. Either we have to download this data sets like preparation of land use land cover can be helped with the Landsat. Then we will prepare the soil map. Then we prepare the rainfall data. And after accumulating all these data set, we will calculate the rainfall. But if you want to do this similar task over another area, you have to perform this task another repeatedly. But with the help of Google Earth Engine, you can directly write a simple some lines of code, and you can perform those analysis, that advanced analysis over entire part of this world. Like one of this case study I performed in estimating the soil loss using Roosevelt. So Roosevelt is a formula to estimate the soil loss, and the full form of Roosevelt is revised, that is soil loss equation, uniform soil loss equation. So if you are using the Roosevelt, you have to create varieties of map like R factor, K factor, LS factor, C factor, P factor. In order to create this map, you will require to have soil data set, rainfall data set, DEM, then Landsat images. And after performing some calculation, you will get the Roosevelt map of particular area. But with the help of Google Engine, you will just write a code once and you can apply those particular data set or particular code in entire part of this world or any particular area. Like in this, I've calculated the soil loss equation of this Mahi Basin, and not only I just calculated, but I have created some interactive charts and result to calculate the soil loss of my particular area. Like I can see that particular Mahi Basin moderate type of soil loss has been occur in more than 35% of area. So this type of analysis can also be performed with the help of Google Earth Engine alone without any exporting data set in external software or tools. Like with the help of Google Earth Engine, we have created a watershed delineation app. Like those who are working in the hydrology can relate to the fact that delineation of watershed is very complicated but necessary task. But with the help of Google Earth Engine, you have developed an app. So you just need to put a particular dot over an outlet and you can create a watershed in your Google Earth Engine platform. Then this is also the available data set in the Google Earth Engine, which we can have the mapping of the surface water dynamics of particular area, that how the water body is changing from time to time. You can analyze for that particular region also. Then we can have the land use dynamics, like if you want to analyze how the land use land cover has changes in duration of time. We know that the Google Earth Engine has archive of data. So the most oldest image of particular Bhopal city I found in 1990. I have analyzed the image of 1990, 1999, 2000 and 2018 and identify that, and with the help of some machine learning algorithm and supervised classification, I have identified that yes, in 2018, the urban area has been increasing drastically and the vegetation area is decreasing in some time of point of time. So with the help of Google Earth Engine alone, you can perform this type of analysis also. And with the Google Earth Engine, with the help of SAR imagery, you can perform flood mapping. And not only in the JavaScript, but you can perform this Google Earth Engine in the QGIS and R platform. Like this is the Python API in which you can utilize some Google Earth Engine application in Jupyter Notebook. So this is the basic introduction of Google Earth Engine. So next task we are going to perform directly on this Google Earth Engine platform. So in order to do that, you just copy this. Just copy this link and post it in the chat box. So you could download the data set for today's training. You just need to go to this link and so in this link, you will get the two type of data sets. One is GE notes. In this notes, we have actually shared some of the codes that we are going to use in this learning process, and we have share a data sets, the zip file. In this zip file, the shape file of Bundelkhand districts in India are available. So you just download these data sets, and you can open directly in the Google Docs also. Okay, so yesterday I have sent you the mail and how to open the how to create the Google Earth Engine. How to create the Google Earth Engine account. So I requested to all of you. So first of all, do you have any doubt till now? Like the presentation which I have shown you?
No,
Like
sir.
any type of doubt or expectation you will need with this training or this session?
Sir,
Yes.
sir, I have performed this watershed delineation in my internship,
Okay.
but I have used this model builder and ArcPython.
Okay.
So this Google Earth Engine can do this in QGIS and all to delineate the watershed delineation.
Pardon?
Like I have performed
Yes.
using model builder and ArcPython to
Okay.
delineate watershed.
Okay.
So to delineate the watershed, we need all this data, right? For satellite imageries and all.
Yes.
So Google Earth will give us this one direct watershed delineation. Like I have got it in model builder. I just given that code, not code, that stream order and all this. I have given
Okay.
and directly had given me the result.
Okay.
So in Google Earth engine, I will get that result in the same way.
No, like this, the Google Earth Engine. Just when we go to this training, we will see that Google Earth Engine can be utilized with the two things. First of all, in getting the data sets. Secondly, in applying some algorithms. Okay, if there is any algorithm available to delineate watershed, then yes, you can do this task very efficiently. But at presently, as of my knowledge, there is no built-up algorithm are available there to delineate the watershed directly. Okay, but as I told you that there is varieties of data sets are available in the Google Earth Engine platform. Like to delineate the watershed, what you will need? You will need the DM. So you can either get the DM for Google Earth Engine and you can delineate your watershed either in QGIS or ArcGIS. So this is some like a layman task or a traditional task. But what we have done, what we have seen that in the Google Earth Engine, already created watershed are already ingested in the Google Earth Engine account. So you need to access those data sets just by calling that particular data set. Like if you want to get the watershed of entire world, can get with the like there is a data set of WWF hydrosheds. So we have already, so they have already created the watershed of around the world. If you want to get this watershed, you can directly download with the help of feature collection and with the help of this particular thing. But now, what I have particular done in the which I have shown you in this particular slide, that what I have done, I have used those data sets which is already creating, like I told you about WWF hydroshed watershed, and I have applied particular. I've created my particular algorithm in the Python, and I've prepared a tool to delineate a watershed on the web based. So I will demonstrate that particular website in this sessions, and I will tell you how you can create your own algorithm so that you can get your particular either watershed or drainage mapping or any other type of data set with your own knowledge and techniques. If you're not getting me fully understand, if you're not understanding how this workflow will done, you will get eventually will get know when will this training goes on in a very basic to advanced manner. Okay.
Okay, sir.
Any other doubt regarding
No,
this presentation?
no, sir. No, sir.
So it is my question to all, to both of you, that have you created your Google Earth Engine account?
Yes, sir. I have
Yes,
created.
sir.
Okay, so I think both of you can visualize, sorry, can visualize this type of like if you type in your web browser that code.earthengine.google.in, you will get this type of interface in your web browser.
Yes, sir.
Okay. So if you are getting this type of interface, that means you are registered, you are authorized to use this Google Earth Engine account. So I think both of you getting this interface.
Yes.
Okay. So what
Yes,
is
sir.
that? So this interface is actually built up of several components. The main is the script, the code editor. Like this is the place in which you will going to write your JavaScript code. And after writing this code, and when you click on run, if the output of this code is in the map format, the output will result display over this particular area. And if the output of this particular code is in the text format or graphical format or some other format, it will going to print in this console panel. Okay. After that, you will get to know about the script, the docs, and the assets of this particular uh, thing, and how to run and save your particular task. So before that, before jumping into the Earth Engine, I'll just going to show you how the JavaScript codes actually work. So you don't need to dig into very detail about the JavaScript. Only very specific tasks, very specific codes are required to get the knowledge of Google Earth Engine. So if you open this documentation which I've provided you, you just need to copy the code like print hello world. You just copy here, and first of all, I will do it by myself. Then I will give it you some time, and you can perform by your own. So first, just analyze what are things actually going on. So what I am doing, I just printing a command of this particular hello world. So I just put a command that is print and open the brackets and give the command in the string. String means this particular inverted commas and click run. So as I told you, if the output of this particular code in this text or graphical format, it will print in the console panel. Okay. So what I can do next thing is, if I want to declare a variable, like, so in order to declare any variable, we will use the command var, and I will give a variable name as variable msg, any message, and I will give name is hello world. So what is actually we are doing? We are just declaring a variable. We are just saying that from now onwards, you will use the, I will actually I'm directing my system that you will use the msg variable as hello world, but it is not printing anything because we are not commanding our computer to print anything. In order to do so, you just write print bracket open msg, and you will get that at the console panel we will getting the word that is message that is hello world. So this is how you can declare any variable or any data type. So there are particular 3 types of data type in this Google Earth Engine or any type of JavaScript or any other programming language, that is number, string, and object or dictionary, and the list also. So you will get to know the difference between these things. Like if you copy this particular thing, so what I actually have done, so this is the comment section. If you want to write a code and you don't want to display it or you want to run it, you can just double hash like this, and it will convert it into the comment. That means if you click on the run, that line won't process. So that means it giving the error length is not defined. So actually we are printing the length, but we are not defining the length because it is commented. I just did this comment and click run. So I can see that my data type of number is displayed here. Next, the data type is like declaring a variable, string. So I just copy next 2 or 3 lines and explain you detail. I just click run. So what is actually basically we are doing? In the first 4 lines, we are declaring actually a number with a variable name length. And in the next line, we are just printing this length with this message. The number is. So this is just a message. This doesn't have to do with my length, but I'm declaring, printing the message with the variable length. So we are getting the number is 99. After that, I'm going the next data type, that is string. So string is nothing but the text format which should be declared in the inverted commas. So what I've done, I've declaring another variable, a string variable known as first name, and I'm printing the first name which is printed as the name is Alan. The next type of data type is dictionary or object. Like dictionary is nothing but declaring any two information in a particular domain. Like I am declaring first name as a string, second name as a string, third thing age as a number, and the fourth thing I color in a string. And if I want to print all those particular this particular person, that means this variable, getting the dictionary is object. That means it has 4 type of object: age, eye color, first name, and the last name. Okay. The next thing is the next data type which are going to use in the Earth Engine is arrays or list. List is nothing but the collection of different types of data types. Like this list is containing 3 strings like Tata, Volvo, and BMW. If you're going to print this cards, that means it's going to print all these particular things. But if you want to declare another variable which is not particular strings like 50, 70 or 80, I just need to put the comma and I just click the run. That means now this list has 6 objects. That means 3 are strings, that Tata, Volvo, BMW, and the next thing is 50, 70, 80. But we don't know what this actually contains. So for that purpose, we are going to use this dictionary. That means for Tata, the speed is 50, for Volvo, the speed is 40. So we can declare the dictionary according to that particular. So these are the data types which you are going to use this particular Google Earth Engine. So this is how you can paste your code here and run on this particular with the help of this button, and you will get the output in the console panel. So this is the just a basic data types with the JavaScript are required. But the next task, or the I can say the main task, begin with the next line, that is Earth Engine objects. So what is the difference between the Earth Engine object and the normal JavaScript object? So if you just copy these 3 or 6 lines, I just paste it here and I click on run. So in the first 3 lines, what I'm doing, I'm declaring a variable that is number and I'm printing that particular variable. But in the next line, what I'm doing, I'm creating a variable with another name, but I'm using ee.number. So EE is nothing but when you are calling any Earth Engine object, then you are going to use this EE.number or EE.date or EE.anything. In order to visualize any type of Earth Engine objects, you can directly go to docs and you can visualize there are n number of data types available to interact with the Earth Engine API. And when I will print EE.number, I just see that when you click on run, you can see that it is actually getting this type of waiting symbol y. But this type of the number, that is the symbol object, is not getting the here sign. Why? Because when you are using the Earth Engine object, that means when you are using this particular EE command, you are actually interacting with the Earth Engine API. But when you are not using this, you are not interacting with the Earth Engine API. You're just directly using JavaScript in your particular browser. So in order to write any code, when you're interacting with the Earth Engine data sets, Earth Engine algorithm, you are going to use this Earth Engine EE.number or EE.anything. So if you want to perform some mathematical operation in that particular normal object, that is JavaScript object, you will just use length plus 1. Like I'm just going to print this length plus 1. So we are getting 100. But when I'm going to print this, print EE number plus 1. So we are getting output as EE.number 1. We are not getting any accurate output. Why? Because we are creating actually Earth Engine object, but we are not utilizing Earth Engine object to do any computation. So in order to do that, what you can do, you can search for Earth Engine object number, like in the dictionary you can see that EE.number. Okay, so in EE.number you have varieties of another objects. Like in order to add, in order to put a sum or this or the addition or subtraction, we have get this dot add. So I just use this command as dot add, right? That means EE.number dot add 1, and I'll click on print. That means we are actually computing in this 100 on using Earth Engine API. So you are actually getting what I'm trying to say, the difference between the Earth Engine and the normal JavaScript object. So if you want to utilize any Earth Engine objects, you are going to use this Earth Engine dot command. Okay, so not only number, but you can utilize Earth Engine object with a string and with a list also. Like if I copy this next 4 to 5 lines. Okay. I just delete this thing and put it. So in the first 3 lines, what I'm doing, I'm just declaring a variable first name as Alan, and I'm printing this first name Alan. So it is printing directly. But on the next line, I'm declaring as Earth Engine dot string. Please hold on for 1 minute. Okay, go somewhere. Okay. So in the next line, what we are doing, we are creating this string that is first name with the help of Earth Engine object using ee.string, and we are putting the first name that is Alan, and then we are printing this. So this also printing the same thing Alan, but using the Earth Engine object. So likewise, this in next step, what we are doing, we are creating a list that is Earth Engine list. That is in the list, when we are going to use the list, we can just directly search for ee.list, and we will get the list. It have several methods also, like repeat, sequence, add, subtract. So what we are giving a list in the this square brackets 1 2 3 4 5, and we are printing this list. But if you want to print the sequence, we don't have to write this particular list. We then you can get this e.list.sequence, in which you can get the start and add, step and count. So I'm just creating a list from 1 to 5 on a regular basis, or sorry, on a regular interval, and I can see that in the Earth Engine sequence, I can see the same list. And if I want to create a list of 1 to 15, I can create this list of 1 to 15. As you've seen that in the Earth Engine list dot sequence, it can ask from start, and in it has two more number of argument, that is step and count, which is not necessary, but is optional. So if I want to print a list in every 2 steps, what I can say, I just give 2 and click run, and I can see that my print has been listed from 1 to 15, which with every 2 steps ahead. So this is how you can work with the Earth Engine basic data sets, Earth Engine data types or Earth Engine objects, and normal JavaScript objects and normal JavaScript data types. So those who are working with the programming, any programming language, maybe this is familiar with you, but you are not familiar with any programming language, this could be new to you, that if you want to interact with Earth Engine API, you particularly need to call this Earth Engine objects and method. So any doubt?
No, sir.
Okay.
Sir, can I get that link, Google Drive link again? It's not opening.
Okay. I'm just going to share again with you. I have pasted in the comment box.
It's working, sir, now.
Okay. So in the meantime, you can just play with this particular and try to understand what is the difference between the Earth Engine and this normal JavaScript objects. So if you feel okay, I just can wait for 5 to 10 minutes. So you just keep on this using this type of creating lists and data sets by your own. And if you have any doubts, I'm there to ask you, because after this, we are going to work with the real satellite data sets. And when you're using the satellite data sets, you need to get clear understand of what is actually methods, what is actually functions of Google Earth Engine and normal JavaScript. Okay. Is a
Okay.
15 minutes break is okay? I'm not saying the break, but actually it is a time by, or you, if you want to, you can share your screen and do some particular stuff. And then if you have any creating any doubt, getting any doubt, you can ask me.
Okay, sir.
So have you tried? Have you tried this codes of creating the data types and variables of list, strings, and numbers?
Yes, sir.
And you're getting, are you able to getting the difference between the normal data type and Earth Engine data type?
I'm not getting it.
Okay. So what is actually basically we are doing? If just see the screen. If I declare a variable number, okay, and I'm giving it 1, and I'm printing that number, so it is just printing as 1. But if I'm declaring the same number at num2 with the help of Earth Engine method, and how to implement the Earth Engine method using this EE dot, and declaring the number method, we have command number, in which n is the capital. If I use this n small, I'm not going to get this particular method. So in order to complete this accurately, I'm just creating Earth Engine number and giving the same number, that is 1. And now I'm printing the same number at num2. Now just when I hit the run, you just see this particular console panel. So it is just display as 1, and when it is display, it is showing as number and computing, because this command is actually happening in the Earth Engine data center. This command is actually happening in your web browser. Okay, but when we are going to deal with the Earth Engine data sets, we are going to use this Earth Engine number. In the simple terms, if I want to say, if you want to apply any mathematics over an image, so I think you are from remote sensing background, so
Yes, sir.
okay, please take. Now you can see my screen. The image is nothing but the setup of pixels like this. Okay. Every pixels denotes some numbers. Like this is a number, this is a number, this is a number, this is. If you want to apply some computation over this image, what you will do? You will just say to the computer that please add number 3 over all this value, or please multiply all this value by number 4.5. If you want to calculate any NDVI or any other type of computation. So what you will do, you will just call this particular image, that image name img, and particularly number as multiply by 5. But it is not going to happen. Why? Because image is the Earth Engine data set. It is the Earth Engine object. But number 5 is not Earth Engine, it is a local JavaScript. So in order to multiply this 5, what you will do, we will do I multiply by EE dot number bracket 5. So now this 5 will become Earth Engine method, and it will multiply with another. You can multiply with any other Earth Engine method or object or data sets. Now you can get a little bit of what I'm trying to say.
Yes, sir.
Okay. Please feel free to ask any type of question.
Yes, sir.
Okay. So that is why what I've done. Now I'm going to print the addition of this number. So if I print num multiply by 7, I'm just getting 7 directly. But if I'm going to use print num2 into 7, I'm getting nan. That means because num2 is Earth Engine object, it is Earth Engine, so it cannot directly multiply by number 7. What I have to do, I have to multiply using any Earth Engine object. So how to multiply Earth Engine object? So in order to do that, you just need to search E dot number, and after searching you will get every method using Earth Engine number. So like we have used add command, now we are going to use either multiply or divide sign, multiply. Okay, I'm going to use this multiply, copy. I'm just using dot multiply 7. So what I'm getting, I just put this 5, and now I'm multiplying this Earth Engine object with another Earth Engine object, that is 7, and I'm getting 5 7s are 35. So this is how you will deal with any number of satellite images. So when we are talking about numbers only, then we can, yes, we can do directly 1 multiply by 2. But when we are using Earth Engine data sets, we have to use this Earth Engine objects and method. Okay. So next, what we are going to use, we are just going to visualize the images and image band in the Earth Engine. So as I told you, if you go to the website, that is Google Earth Engine, you will get the enormous amount of data sets, the data catalog. Okay, like if I click on this data sets, you can see there are varieties of data sets like Landsat, MODIS, Sentinel, and apart from that, temperature data, climatic data, atmospheric, weather, Landsat, Sentinel, MODIS, high resolution, terrain, land cover. And if you want to search, you can directly put it here. Like if I want to get the DEM, like SRTM DEM. So I think Ashutosh, you know about what is DEM actually?
No, sir.
No. Okay. So DEM is nothing but the digital elevation model. You know about the topo sheet?
Little bit.
Okay. Or we can say contour map.
Yes, sir.
Okay. So what is actually contour map? If you try to recall, the contour map is nothing but the lines joining the same elevation profile.
Yes, sir.
You know, if I see the contour map, or if anyone who sees the contour map can easily analyze, yes, this is the area which has some high elevation values, and this is the area with some low elevation values. So when we convert the contour map into the image format, we will get the particular DEM. And how this particular thing is work, like I have shown you in the whiteboard. Like this is an image is nothing but the set of pixels. Okay, so if the pixel values denotes the, like the pixel value is 500, and this value denotes the height in meters from, or height in kilometer or feet, or in any unit from mean sea level, that means this particular image is nothing but the digital elevation model. Okay, so you will get to know more about when you are going to use this data set.
Okay, sir.
Okay, so if I search SRTM, I'll get the various type of SRTM product. So I'll just click on NASA SRTM digital elevation, and here I can visualize the data set is available from, because this is a single tile, this is a single DM, this is by a provider, this NASA, and the code to call those particular data set is ee.image USGS SRTM 003. So in order to read about any data set, you just go to the website and search for the particular data set, and you can get the band. Like it has only single band, that is elevation. The unit are in meters, and the values are from -10 to 6500, the 30-meter pixel size. So in order to get this DM, I'm just going to call the image. I'm just going to, first you just see my screen and then you can perform your own analysis using this particular document. Okay.
Okay, sir.
So I'm just going to paste this data set. And in the first line, you can see that first line is commented. So it is not going to read this, but you are also you're always advised to use this quotation mark so that after a few months or few days, if you're going to read your code, you can what we can say, analyze that yes, this line is doing particular thing. So with the help of this line, we are calling the image with the help of ee.image. So this is the earth vision method to call an image. So the keyword of that particular SRTM image is SRTM934. And how do we get that? We are search for SRTM and we are getting this code from this. You can copy this, or you can get this version 4 also. This is another version of this, like SRTM. Okay, this is the 90 meter initially, and I have selected the particular band of elevation because this image contains one band elevation. So I'm calling that band, that is select elevation, and I'm printing run. So see, nothing has happened in the screen, neither in console, neither in panel. Why? Because I have nothing, I'm not displaying an image or not printing. So with the help of next line, what I'm doing, I'm just printing, adding the image. So in order to add the image, so I have told you this is the map panel, and in order to use any method using the map command, you just map dot, and when you search for this map command, you can see there are varieties of methods. Like presently we are going to map dot add layer. We are going to use map dot add layer, and we are going to add the elevation layer, and we'll just print run. And I can see this, the SRTM DM of whole world can be visualized with a single click. Okay, so next, what I want to do, if I want to zoom my area on a particular location, like if I want to zoom to a particular area, you can use this particular line, that is map dot set center to this particular latitude and longitude with a zoom label of 9. So this is nothing but the latitude longitude of New Delhi. When I just click run, both the things are happening. We are actually adding the elevation layer in my map panel, and we are centering my map over the New Delhi. And when you want to visualize this data set, you can get this data set in the layer panel. Okay, so can you visualize anything? No, but I've unchecked this. You can visualize this. This is the New Delhi, and this is the DM of your particular area. Now, if we want to get the metadata of this particular DM, what you will do? You just print this data set. I'm just using print command. So we are actually doing 3 things. We are adding a layer, we are centering our to New Delhi, and we are printing the data sets. So I print the elevation. I can see that this is an image of one band. The ID of this particular image is SICAR SRTM, and the bands are only one, that is elevation band, and they are properties. In order to extract any type of property, like this is the shuttle radar topographic mission, the metadata of particular satellite product. In the next task, in order to visualize this image more prominently, what we are going to do, as you can see, this is only a black image. This is not actually depicting anything. So in order to visualize this image more prominently, this is a gear sign. You just click on this, and as we know this is a single band image. This is not a 3-band RGB. So I just click on single band, and I just put in the stretch 100% mode, and I can see that in a particular area, my elevation range is ranging from 175 to 356 meters, and I click apply. And after that, I can see, yes, the image is now more prominent to visualize. Okay, so now you can enhance, now you can visualize that, yes, this is the particular white area is of high elevation, like this is the area, and the darker area is of low elevation. Okay, if you want to analyze the particular pixel value, how you can do that? You just go to the inspector tool and click on the map to inspect and layer. I just click on a particular location and I will get the elevation of that particular pixel is 214. As I've told you in the this is the image, that if this particular value is 500, that means of DM, that means this particular is 500 meters above the mean sea level. If the value of that pixel is maybe 224 meters, that means this area is of lower elevation than this area. That means this is the area of higher elevation and this is the area of lower elevation. So we are actually inspecting like this. If you zoom to a particular location, you can see this, the image is nothing but the made up of pixels. Like you can see clearly visualize the pixels. If I click on this pixel, I'll get the value as 257. If I visualize on this pixel, I'll get the value of 246. But still, the visualization is not very up to the mark. So what you can do, you just what we can say, create the color platelet. Like you just click the platelet and apply the different color, like the lower elevation with the sea with the red color, the higher elevation will be the yellow, then more higher will be the green, and more higher will be the blue. I just click OK, apply, close. Now I can see that I can see that, yes, my digital elevation model is now more and more prominent in the visualization. I can see that this is the area of some higher elevation. Okay, if I zoom out to a particular extent, I can see that this whole area is visualizing in the blue color because this is the Himalayan range. And now why it is all coming in the all single blue color? Because the range of this particular value is only 316. So after the 316 is the value of pixels more than 316, all the data will be visualized in the blue color. In order to distribute this color uniformly, you just again click into stretch 100% and click apply. And now you can visualize more accurately that here this is the pocket of some higher elevation and this is the some pockets of some lower elevation or some valleys. So this is how you can visualize your uh, digital elevation model or any single image available in the Google Earth Engine. Okay, in order to like if you don't want to display the image using this particular layer man, what you can do, you just copy this color platelet and paste it over it. So what we are actually doing when we use the map.edge layer, it is asking three types of, 4 to 5 types of input, like Earth Engine object. The first thing is asking the Earth Engine object. So we are putting Earth Engine object as elevation. Elevation is nothing but the image. Then visualization parameters. So we are using visualization parameter as that the values beginning from 0 to 3000 and the platelet will be blue, green and red color and the name of that particular tile. So we have given the name of that particular tile as custom platelet, and when I just click run, because the range is very high for Delhi area, I just decrease from 300, and now Delhi area has height from 0 to 300. Now I can visualize that lower elevation will be from the blue color and the higher elevation area will be with the red color. So you can utilize this type of image color format, or you can directly change the color format from here also. Okay. So if you want to inspect any element, you just need to click the inspector and you can check this particular area that yes, this area has elevation of 236 and this area has the elevation of 1600. So this is how you can visualize a single image or a single band of a particular image. So will you try to do it on your own?
Yes, sir.
Okay. So I think Mr. Ashutosh, you will get the very basic idea of what is actually DM, because later on we are going to do this task on a multi-band, multi-spectral data set, which have not only one band but have a several band. So the basics of images or remote sensing is must to using this Google Earth Engine. And Ms. Darvinia ji, I'm correcting.
Yes, sir.
Are you getting anything?
Yes, sir, I'm getting, sir.
Okay, because you know about the DM actually.
Yes,
So
sir.
in order to use the DM, what you actually do, you download the DM, you put on your geospatial software like QGIS, ArcGIS, and you do the
Yes,
stuff.
sir.
But with the help of Google Earth Engine, you can visualize the DM of entire world by just single click. And if you want to do some analysis, you can do that also, but we will do in the some later part.
Okay.
Okay, so it is my advice you both to do what you will do, just copy this code and paste in your code editor and try to analyze each and every line, that what is each and every line actually doing. And if you are getting any doubt, you can ask me,
Yes.
because then and only you will get to know some advance of this Google Earth Engine.
Okay.
Okay, sir.
So I'm waiting for 10 minutes more. If you have any doubts, please ask me. I'm there for you. So are you performing anything?
Yes, sir.
Yes, sir. I have performed.
Can you share your screen?
Yes,
Both
sir.
of you. First, Mr. Ashutosh, you just show me what you have done.
Okay, sir. So there is an error.
Regarding.
Host is disabled. The participant screen.
Okay,
state.
okay, okay, okay. Now you try to share. Okay. So you are actually getting what this actually all the 3 to 4 lines are doing.
Yes, sir.
Okay. So in the line number 17, you are actually the map dot add layer. First of all, you are adding the map elevation map. Then you are doing the value of minimum to maximum 3000, but you are not denoting any color. So what it will do, it will just do in some black and white color. But if you give color, like in the next line, you haven't, I think, written it. You can visualize the image in the color also. So you're getting what you are actually doing.
Yes, sir.
Okay. Now you can stop your sharing screen.
Okay, sir.
Now, Miss Darvinia, you can. Pardon, I'm pronouncing your name might be wrong. How to pronounce your name?
So it's Darwinia.
Darvinia. Okay. So actually, you're basically from GIS background, so you will actually know what you are doing.
Yes, sir.
Okay, you have created the DM, and now you can visualize to your particular area. Okay. Now good. And now you can stop your screen also.
Yes, sir.
Okay. So next, what we are going to do, we are going to visualize the Landsat data set. Okay. So as you know that Landsat data is multispectral data. That means it is the combination of various elevation band. So in order to search for the Landsat data set, you don't need to search anytime on the Google, but you can directly search it from here, like Landsat 8. Okay. And you, after searching from Landsat 8, you can get varieties of Landsat collection like raw scenes and top or test morphology correction like tier 1 and tier 2 and varieties of data sets. You just click any of them one and you just click on bands. So you will get to know that a Landsat 8 is the combination of more than 10 to 12 bands. Okay, each band has a separate properties, like the band number 1 is B1, denoted as B1, and it is a coastal aerosol, which is not very much of useful. The next band is a blue band, green band. As you have seen in the slide of remote sensing, that wavelength, the human eye can detect the blue, green, and red band. After that, the satellite data also comes with a near infrared band, shortwave infrared, and other type of panchromatic Sirius band. And each band has a certain limit of from wavelength, like 0.4 to 2.45, 0.5 to 0.59. So these are some different spectral signature of that particular band. And in order to call those image, the code for using this image is Landsat LC08 LT1. But please remember here the object name is image collection. That means when you are calling more than one image, you are going to use image collection. But presently, we are just calling a single image. So in order to call any single satellite Landsat image, I just provided you a code if you go into this document, you will see that you just copy the code and paste it here and run it. So you will see that each and every line is doing. So first line is calling the image of with the code ID Landsat LC08C T1 surface reflectance. And for that particular image collection, I am calling a single image of LC08, that is Landsat, with a path and row of 146 and 044 from the date of 3rd of March 2021. So this is the whole code of calling a single image. Okay, and after calling the image, what I'm doing, I'm actually adding the layer in my console panel. So what we have actually do, I'm calling the Landsat image L8 object, and in order to visualize, I'm visualizing in the FCC color, that is false color composite. In order to do that, if you don't want to do this, like I'm just going to comment this section. So, map dot add layer, and I'm just adding L8 and I click run. So what you will get an image with a black and white color. Okay, you cannot see anything. Why? Because the visualization parameter are not set to the optimum value. So in order to do that, initially what we have done, we have created the visualization parameter with one band, but now your image contains more than 3 bands. So you will going to project this image as RGB color, that is multispectral. So in the remote sensing terminology, that there are 2 times basically you can visualize any satellite image with some different combination of band. Like if I say true color, so true color means the color which are visualized by the human eye. That means red, blue, and green. And if you want analyze this metadata of this Landsat, that means the true color contains band number 4, 3, and 2. So what I will do, I'll just visualize my image in band number 4, band number 3, and band number 2. And I click on stretch to 100%. And I will keep on this gamma, not the platelet. And I just click apply. So now you can visualize the image in more prominent way, like you visualize any type of image in the normal Google Earth platform. Okay, now you can visualize this. Yes, this is the water body. Okay, now you can visualize, yes, this is the vegetation, but not very clearly. And you can visualize that this is the road. But in order to visualize more prominently, there is a term known as false color composite. So in order to visualize the false color composite, the band combination is band number 5, 4, 3. So this is just for visualization purpose. Again, clicking on stretch 100% and click apply. And now, like Mr. Ashutosh, I think you are from agriculture background. So now you can clearly visualize the agriculture and non-agriculture area. Like, yes, this is my agriculture area. This red is my some meshy type of area, and this can be my fallow land that presently it is not agricultivable land. So with the help of false color composite, you can visualize your image more prominently. Okay. But
Okay,
if you don't want to put the parameter from this, you can directly add your image like this. In the visualization parameter, what I've done, I've given the band 543 minimum and maximum value, and I just close it, run. And in the next line, what I'm doing map.center object. In the initial code, what we have done, in order to focus on my particular latitude, longitude, I have used map.setCenter. So set center required geometry, right? Latitude and longitude. But when you are using center object, you will just require the Earth Engine object. So what is actually we are doing? We are focusing on this particular image and we are printing this image. And in the console panel, you can see this. This is the image with the type image. This is the Landsat. This is the bands. There are total 12 bands. Like I have told you, band number 1, band number 7, 10, 11, and 3 extra band. And these are the properties. Now, in order to visualize this, if you see this inspector tool, I just click on inspector and you click any of the particular area. So you will get the band value of all the bands. Like in this particular area, the B band value is 438, band 2 is 549, and band 3 is 769. That is the signature of that particular. You can visualize in the graphical format also. So this is how you can see any spectral profile of particular band or particular area. Okay.
Okay, sir.
So this is how you can play with any type of single image. So not only the Landsat or SRTM, now you can visualize any other type of image. Like if I search for NDVI, we know that Earth Engine has also contained the MODIS NDVI dataset. So if I search for NDVI, like you are from agriculture background and you are also from a remote sensing background, so you both know about a little bit of what is NDVI. So I just click for MODIS NDVI. But it's not a single image, it's an image collection. So I will tell you later about this. So this is how you can call the particular image or particular band. So if you don't want to write this visualization parameter, like if I don't want to write this, but you can create it like so what it will basically do, it will project your image in the black and white format, but you can, as I've told you, you can project it accordingly, like band number 4, 3, 2, stretch to 100%, apply, and you can also import this visualization parameter. So just observe, if I click on import, there is a visualization parameter added in my console. That is the parameter, and I have to just call this method and paste it here. So next time I don't have to set this visualization parameter again and again. It'll just automatically added with the help of this particular line. Okay. So next we are going to work with the image collection. So now what is actually image collection? So have you seen in the in my slide? This is the image collection. That means if you are calling a Landsat image or if you're calling any rainfall data set, you're calling entire series of that particular collection. Okay. So when you see the Landsat 8 data set, Landsat 8, and click on any one, you will see that it is the code of Landsat IDF, but it is calling as image collection because it is not a single image, it is a collection of several images. So here I've written a small line about it, that image collection refers to a set of images in Earth Engine. For example, all the Landsat 8 images in Google Earth Engine are an image collection. In the code editor, you can work with an entire collection. If you want to perform any analysis over entire collection, you can do that, or you can filter a particular data set according to your own need. So in order to call any image collection, I'll just copy this code. Close. I just delete this. I just copy this code and click run. So What I'm doing, I'm just calling the entire Landsat 8 imagery, but I'm not either printing or not visualizing over my area. So next task, what you will going to do, it's my suggestion to do it on your own self. You will just visualize this Landsat 8 image collection and print this L8 collection on this console panel. So how you can visualize, like in the previous example, you can see that it can be visualized with the help of map.add layer, and you can print it in the console panel as print in the bracket L8. So with the help of these two parameters, you are going to visualize this image or this entire collection, and you are going to print this collection over here also. Can you do it yourself?
Yes, sir.
Okay.
Yes, sir.
Please try to do, and if you want to share your screen while doing so, you can do. If you're getting any problem, you can share with me. Are you getting anything? Are you able to visualize this entire Landsat 8 collection?
Yes, sir.
Okay. Now the difference between this project adding layer of single image and adding image collection is that in a single image you are going to add layer only for one area, but now I am projecting entire Landsat 8 collection. That means I am projecting image of around this world from, like, Landsat 8 is available from 2014 to 2000 till date. So I'm going to visualize this. So this will take some more time. But if you focus to a zoom to a one area, particular area, you can see that I can get number of tiles, like this is a tile, this is another tile, and this is another tile. And if you try to print this, Has anyone tried to print this collection? If I try to print this collection, it will give an error. Yes, if you're trying to print this error late collection, it is giving an error. Collection query aborted after accumulating over 5,000 elements. That means if you try to print any image, which contain, if you want to try to print anything which contain more than 5,000 element, 5,000 images, 5,000 feature collection, it will give an error in order to just print. But you can perform your analysis anywhere else. So in order to do that, like here I have written this, an error message is written in the console, the print collection query, because you have to, now you have to filter your image collection. So what is actually filtering means, you have a number of data sets and you know that you will only need a particular data set of particular date and a particular area. So that thing, so in Hindi it is known as chatna. I don't know if it's comfortable in Hindi, but in order to filter your data set according to your area, according to your date, and according to some other metadata, there is a technique in the Earth Engine is known as filtering. Okay, so are you getting at this error or not? First of all, you get the difference between the image collection and image.
Yes, sir.
In
Okay.
my showing something other kind of error.
Can you share your screen?
Yes, sir.
See, this if this kind of training, if you are getting an error, if you are not discussing, then you will keep lag behind. Because next task is important, because each and every task is important for the next task.
Yes, sir. Sir, it's showing.
Okay. I just first stop my screen. Yes, now you can share. See, the error is saying L8 is not defined. So in the fourth line, you are using L8. But is there any object name L8 here in the line number 2?
No, sir.
No. What is the object name in line number 2? Variable name. A variable name. L8
Yes.
underscore collection.
Yes, sir.
So you use the L8 underscore collection in line number 4, 6, and 7. Then you won't get the error. Just copy the L8 collection underscore collection. Copy the L8 underscore collection, line number 2.
So that is
Yes. Copy this and now paste in the instead of L8. Yes, now here in the line number 6 also, and in the line number 7 also. Please please delete the line number 6 because it is showing that map center object, but L8 collection is not a single object, so you can delete it. Now you can yes, now you can click run. Okay, the print, the capital, the print is not with the capital P, small p. Okay. Now in the print console panel, you can see this. There is an error like consolation query aborted after the 5,000 element, but in the map layer, you can visualize your image. Okay.
Yes,
you can change the visualization parameter later also, but your image is there, but print cannot be possible. So in order to do that, what we are going to do, we are going to use the filter. Okay, so when you go to the code, this document, you will see this. We use the filters to select the appropriate images. There are many types of filter, like if you see the filter module, like we generally use the three type of filter, like filter by metadata, filter by date, and filter by date location. Suppose you want to get the Landsat image of New Delhi of around 2001 January. So what you will do, you will apply filter over this L8 collection. How to do that? I just copy this line. Okay. And paste it here. So in the first line, what we are doing, we are creating a geometry. Okay. So either if you want to select an image for a particular point, you can define that particular point with the help of ee.geometry with the latitude and longitude given for your own area. Then in the next line, what we are doing, we are getting my center object as geometry. Then in the next line, we are calling the Landsat image, and then we are applying a filter. As you can see that L8 collection dot filter, and in the filter we are using filter dot date. So if you search for filter, you just go to the docs, okay, and you search for ee.filter, and e filter has how many of filter, like filter dot bounds, filter dot collector range, and filter dot date. In the filter dot date, you can visualize that it is asking two arguments, that is start and end. It has to be date, number, or string, and has to be date, number, or strings. So what I'm doing, I am just calling the starting date and ending date. So this is the 1st January 2021, and this is the 1st February 2021. The last day will not be included. So we are actually calling the image of January 2011. Sorry, 2021. And I just click on print, copy filter, and I'm just adding this map, add layer, filter, and I'm just clicking on run. So first it's create a geometry with the latitude, longitude on this point, which is of Delhi area. Then I am calling the image collection. Then I'm filtering my image collection only of this date. Okay. And then I try to print the image collection and map.add layer. So if I see that the print has given an error of collection query aborted after, because I am just visualizing my point, but I am not filtering my data set with the help of this geometry. So in order to filter this data set according to my location also, I have filtered my data set with the date only, not with the area. So in order to filter your data set with the location, you can copy this line, like filter by location, and paste it here. So I'm creating filter 2 and creating another filter from filter and printing filter 2 and map.layer filter 2, and I just click run. Now I am getting image collection which is contain 2 element. That means over this particular area of Delhi from 1st January 2021 to in the January month, there are only 2 Landsat image. If I just click on features, I can see there are 2 images. One is that this denotes the row and column, and this denotes the date, that is 11 January 2021 and 27 January 2021, and it visualize only this particular image. So you can set the particular band combination like we have done in the previous one. So now it is looking more. It is a cloud cover image, but we can eliminate that also in the later stage. But now we can able to visualize, or we can able to get our data set more prominently. But if you don't want to, like in this command, what we have to do, first we are filtering by the date, and we are getting the result in the variable name filtered. And again, we are using the filter by bounds using the geometry over this filter image. But this can be done by a single line only, that is lens set collection dot filter rate dot filter bounds. I just copy this command and paste it over here. And just run it. Oh, sorry, I forgot to add to map at layer. And also we are getting the, but have changed the date like 2019 to 2020. So for whole year, we are actually getting 41 images. Okay. Now you are getting what we are actually doing.
Yes, sir.
Okay. You, Ms. Darviniaji, you can getting what I'm actually trying
Yes,
to
sir.
tell. Okay. So we are actually filtering the data set according to our own area or our own dates. Now you can filter the data set according to the path and row. Okay. What is path and row? Actually, path and row is nothing but the details or the metadata of any data set. If you click on this image and I just click on band features and I click on any type of like these are 41 elements, like so these are 41 elements, like 41 images. And if I open any one and check the properties, so I will find that there are approximately 119 properties through which metadata can be acquired. So like if you read detail about the remote sensing in GIS, you will get to know about each and every type of like this metadata, like the data acquired, the data type, and the geometric RMSE model, like the correction model. And there is a the location of this tile is stored in the WRS path and WRS row. So I know that the Delhi in the Landsat image comes in the path and row of 146 and 40. So now you can see this. These are two tiles are coming up. Okay, why? Because if I add my geometry, so in order to add this geometry in the map, you just use map.add layer. I just click. Okay, this dot is my geometry. I just put it above here. Okay, so you can see this. This is my point, and this is the point where two tiles are combining. So it is actually visualizing both of the tiles. But if you want to get only one tile, either this or this, so you get to know about this path and row of this particular tile. So I know that my actual image is of 146 path and 40 row. So what I will do, I'll just copy this area, copy this code, and I don't need the geometry also here. And just click run. Sorry, map.add layer, collection. So you can see now I can only visualize a single tile only because I have extracted my data set with a path and row, and it cannot be common for two tiles. So this is how you can apply the filters and create your or extract your particular image from a date, area, or anything metadata. Okay, so in the further exercises, you will get to use the mainly two type of filter, that is filter dot bounce if you want to create your own particular area image, and filter dot date. This is one of the most important filter when you're using any time series analysis. Okay, so
Yes, sir.
yes, any doubt?
No, sir.
No, sir.
Okay. So the next thing is we're going to learn about composting, masking, and mosaicing. So the default order of this collection is by date. Like if I print uh, this collection, so I can see this there are total 162 number of tiles, and it is automatically sorted by date. Like it is the 11th of April of 2013, and the last image is, that is the latest image is 3rd of May 2021. So the default order of the collection is by date. So when you are displaying the collection, it is implicitly create a mosaic within the latest pixel on the top. So actually you are not visualizing this 161 image. You are visualizing only one image. And which image? The image on the top, that is the latest image. If I click on this pixel value, you will get the pixel range of each and every band of each and every image. Like this is the for latest image, like mosaic image, it's your latest image. But if I click on series, you will get for each and every band of each and every date. But if you want to convert this image collection into image, you need to learn about composting, masking, and mosaicing. So you can call dot mosaic on image collection to create a mosaic image. You can create a composite image by applying a selection criteria to each pixel from all pixel in the stacks, like median or mean or sum or any other data set. So what is actually, so first of all, try to run this code and see what is actually we are doing. I'm just going to run this code. Okay. So in the first line, what I'm doing, I'm just creating a geometry over my Delhi region. Then I am calling an image collection. This time I'm calling Sentinel-2 dataset. So Sentinel-2 is maybe you know that Sentinel-2 is of 10-meter resolution. It is one of the highest resolution satellite dataset which is freely available, and we are calling image collection in the variable name of S2. And this is the visualization parameter of true color composite. And now we are filtering dataset with the help of three filters. One is filter.lt. So what is actually filter.lt is doing? If you search for it, so filter.lt. Filter the metadata less than a given value, the property and the node. That means if I okay, so If I see, look at this. This is the Sentinel-2 data. I will search for it and analyze this data set first. Okay. So these are the bands, like band 1 is aerosol, band 2 is blue, green, red. It is of 10 meter, then red edge, then NIR. And these are some properties. Okay. So in this properties, there are a number of things like cloud pixel percentage. It is in a double format. So that means that particular in a particular tile of that particular image, what is the cloud percentage? So if I want to filter my data set according to cloud percentage, so we are using this filter set. So what is actually doing? It is selecting only those images which has the value of cloud pixel percentage less than, that is LT, less than 30. Then in the next filter, we are filtering with the date. That means from January 2019 to 1st January 2020. And then we are filtering with the bound, and that bound is nothing but a single geometry. After that, what I'm doing, I have created a mosaic name as dot mosaic. Then I create a median composite, that is dot median, and I'm visualizing 3 of the data set. Like first of all, I'm going to visualize the filter data set. Like in the previous example, I'm going to visualize this mosaic data set, and I'm going to visualize this median composite. Okay, the visualization parameter is same in all the things, RGB vision, this, and this is the name of all the 3 images, and I click run. Now try to analyze all the 3 data sets. Now, if I zoom to a particular area, and if I visualize only filter collection, so what I can see is there is a cloud over a certain area. Okay. And as I said, I am just visualizing this filter area as it is. So that means if you are visualizing any image collection, that means you are visualizing the latest image of that particular area. Okay. Now, next thing what I have done, I have created a mosaic with the help of dot mosaic. So if I search for image dot image collection, okay, in image collection there is a method known as dot mosaic. This is the mosaic. So what is actually doing? Composite all the images in a collection using the mask. So what is actually doing? It is converting the image collection into image, but the image will be the latest one. So the pixel value of this particular mosaic will be the same as this filter. If I click on inspector and I click on anywhere on the pixel, okay, so this is the result of mosaic image. The band 1 is showing the band value as 2017, and in the second image, that is the mosaic filter image, it is showing the 2017. But in the median image, it is not showing 2017, it is showing some another value. Why? Because what we are doing in the median image, if you visualize the second image, that is median composite, it is cloud-free image. You can see it is a cloud-free image. So what actually we are doing, as I told you, that image is nothing but the set of pixels. Okay, so this is and the image collection is a combination of several images. Like this is the collection of maybe 2 or 3 images. This is the image 1 and this is the image 2. So it has some common pixel, like this is the pixel 1 of image 1 and this is the pixel 1 of image 2. So when I'm trying to visualize this filter data set, that means I'm going to visualize. When I'm trying to visualize this filter data set, that means I am visualizing the latest image. Okay. But when I'm trying to display the mosaic, so mosaic is also what is doing, it is converting my image collection to a single image, but the pixel value of the latest image will be remain as it is. But if I want to display the median image, so what is the median image is actually doing? It is calculate the median value of all the image of this particular pixel. In this particular pixel, maybe there are 3 or 4 images. So like this is the pixel number 3 of image 1, 2, 3. So it is calculating actually median of all the images. Okay. So you will get to know more about this in the future example also. But it is my request to please go and try to print this. First of all, try to print this thing and see in the console panel. When I've printed 3 things, that is filtered, mosaic, and median composite. So when I try to print, we see this first is an image collection, the second mosaic is an image only, and the third median is an image. Okay, so I'm not filtering or using any composite function, so it is as a complete image collection. This is a single image, it is the latest data set on the above, and this is the median composite. Likewise, this you can use the median filter like sum or mean or what you can say standard deviation also. So all the statistical parameter can be used visualizing over particular area. So are you getting a little bit of it or not?
Yes, sir.
Yes, sir.
Okay. So now what we will do, we will try to use this median or this sum command over the rainfall data set. I think both of you are very well equipped with the rainfall data set.
Yes, sir.
Okay. So first of all, I'll just search for rainfall. So here we have varieties of rainfall data set like TRMM, GSMAP, but presently I'm going to use the CHIRPS data set, CHIRPS daily. If I get in here, okay. So these are the CHIRPS daily data set. I just click, I just open in the new tab. And here you can see that images available from 1981 to 2021. This is the image code, and it has only one band, that is band name is precipitation, and this is the resolution, which is 0.05, that is approximately 5 kilometer, and this is the sample code. Okay, so what I will do, I just copy this code and put in my screen. Run. So now you are only able to tell me that what is actually doing in each and every line. Can you tell me what is we are actually doing in the first line?
So in the first line where we will be collecting the images of the rainfall, the satellite
Okay.
images.
Okay, and anything about filter?
Between the dates.
Yes, we are applying here filter also.
Yeah.
Because we know that the CHIRPS data set is available from 1981 to till date. So we are actually extracting on data set of only 2018 of May, 1st May, but I will just put it on August, and it is September. Okay. Now I'm filtering my data sets of 2018 August. And in the next line, what I'm doing, I'm selecting a particular band because it contains only one band. So I don't need to do that. But later on, if image maybe contain 2 or 3 band, So I need to apply this line, that's select precipitation. In the next line, I am just visualizing using the visualization parameter. So this is just for visualization purpose. You don't need to use this. And in the next line, we are setting my map to a particular lat long, and we are displaying our image. So I just use this lat long over my Delhi region. And this is the zoom level. I just click run. Now I can visualize the image. Okay. So can you tell me, like I am visualizing the image collection of 30 days. I just try to print this data set. Print precipitation. So I am trying to call the 31 images. So, but the image is showing only of single date. So can you tell me of which date the image is showing to me? Like this is a first date, or this is a last date, or a median date. I am visualizing image collection here. As I told you, the default order of the collection is by date. So when you display the collection, it implicitly creates a mosaic with the latest pixel on the top. That means the pixel which you are visualizing is nothing but the rainfall of the latest data set. That means 31st of August. Okay, but when you do the inspection of any particular area, like if I click on inspector tool and click on particular pixel, okay, the mosaic precipitation is 0. That means the rainfall on 31st August over this pixel is 0. But if you click on series, I can see that yes, on the 29th of August, the rainfall is other of 25 value, 25 mm. Okay, but if you want to visualize the rainfall of total, the sum area, the sum rainfall, so what you will do, you will create a mosaic of variable sum precipitation dot sum, and I just print this sum and visualize my map dot add layer. The visualization parameter, I'm not going to change it. I can increase this visualization parameter like 200, and I just give it sum. Run. Now I can see this. I am calling a single image. Now this is not an image collection. This is only a single image, but it is showing in the red color, completely red color. I just zoom out. Okay. So now I can visualize that yes, in some of the area, like in this area, in this particular area, the sum of August rainfall is very high, but in this area, the sum of August rainfall is very much low. So this is how you can apply this composite filter like median, mode, and sum over varieties of image collection. Now you can visualize more enhancedly. So if I want to if I want to analyze a single year rainfall data set, like January 2018 to 2019. As I said, the last date is not inclusive. I just do 2000. and just analyze the data set of India only. So now you can see in 2018, because when we are doing the any analysis over rainfall data, we are using either daily, monthly, season, or total annual. So we can see this. This is the belt in which we are getting very maximum rainfall, like in the northern part of Uttar Pradesh, Uttarakhand, and over whole of northeastern state. Then in the western coast, we are getting the maximum rainfall, and we are getting the median rainfall in the central region of India, in the state of Bihar, and we are getting very low rainfall in the region of Rajasthan and over this area. So this is how you can create any mosaic of a particular image. Okay. So are you getting getting the difference between what we are actually doing of creating any median some images? Why we are doing that?
Yes, sir.
Both of you are getting it or not?
Yes, sir.
Okay. Okay. So this is a task which you can perform. Like you can create a median composite of Landsat of 2015 and 2020. Okay, and visualize the difference what is actually happened with 2015 and 2020. If you want to compare, like if you want to get the change detection of any particular area, you cannot analyze using a single date image. Why? Because on a single date you can get the cloud, on a single date you can get the different type of atmospheric and other topographic condition. But if you create a median composite, you will get the median image of particular year 2015 and 2020, and you can compare what is actually happened and change in the particular cities, like the urban area has been increased or decreased, or the water bodies has been reduced or increased. So you can visualize with the median composite only. So this exercise I let up to you only. You will have to perform this kind of exercise. After performing, during performing this exercise, if you get any error or any doubt, you can contact me. Okay. So next thing, I'm going to switch over to feature collections. So now till now we are talking about image collection. Image collection is nothing but the collection of images. But when you are doing any GIS analysis, you need to get to know about various vector data set. Okay, like shapefile. So in the Google Earth engine, the shapefile or the vector data is known as the feature collections. So feature collection are nothing but the vector layer in any GIS platform. It is similar to image collection but made of features and not images. We can load, filter, and display the feature collection using similar techniques that we have adopted the other data set. Like there are certain types of what we can say, certain types of data sets or feature collection which is already loaded in the Earth engine. So for today's purpose, I'm just going to visualize this administration boundary, and I will give you a small task and you can perform on your own. And on the next session, on the next day, we're going to continue with that. So I just copy this code. So before pasting it, when we are using so much of work, so we need to save our data set. So like if I want to save my code, so there is a button known as save. When you just click on this save, it will ask you to create a repository. Like initially I have created my repository as like basic. If you want to create your own, you can do it, and you can give your file name like this is the rainfall data set. So I just give rainfall on the training and I just click OK. Okay. So if I see this is all my work that I've used, the rainfall training has been saved. If I accidentally close this button and I open it again, my Earth Engine code editor, I can recall my code because it's already saved in my profile. That is rainfall training. I just click on this and it automatically loaded into my console panel. Okay. So next we are talking about the feature collection. So I just copy this code and paste it here and run and see what is actually happening in my map. If I zoom out to a particular extent, I can see the district boundary of Madhya Pradesh state is displaying in the red color. So what is actually we are doing? Here with the help of EE.feature collection, we are calling the feature collection known as FAO GAU. So this is the data set which is already ingested in the Earth Engine archive. So I just search for it and see what is data set is all about. So this is the version of Gaul dataset is simplified at 500 meter. So this is the administrative unit of all over the world. And in order to call this dataset, you will see the code feature collection dot this code. Now this is the table schema. Table schema is nothing but the attribute table. And when we are talking about the Excel, the spreadsheet, the column name is nothing but this attribute table name. So here we know that the country name is displayed at ADM0_name. The state name is loaded as ADM1_code, and the district name is coded as ADM2. So what we are actually doing, first we are just calling the admin data. If I display the whole of the admin area, what will display? Add layer admin. Run. What is actually happening? It is displaying the data set of whole world. Like this is the district boundary of whole world contained in the data set of this ID. Now, if I want to filter data set of my particular own area, so as I told you about the filter, okay. So in the filter, I have taught you about the how to filter your data set with the metadata. So I know that the state name is loaded in the ADM1_name. So I'm using that the filter as filter.eq. So what is actually filter.eq does? So I just go to ee.filter and I search for filter.eq. Filter to metadata equal to given value. Okay, so this is the property of the name and this is the value. That means it will filter the data set in which admin1_name column will be equal to Madhya Pradesh. And I'll just give the visualization parameter and display my result and run. So what is actually happening? It will display the data set which has the value of Madhya Pradesh in the column ADM1_name. Okay, if I inspect any of this column, I can see this. The ADM underscore name is Madhya Pradesh. The ADM2 underscore name is, that means the district name is Rewa. And this is the shape area and this is the shape land. Suppose if I want to get only my district, so what I will do? I will just use the column name first, that is ADM2 underscore name. And I want to display my, just like Bhopal city. Okay, I just click run. And I also try to print the data set. I just click run. And in the console panel, I can see this. This is the 0 element and map is not showing anything. Can you tell me why? What could be the reason behind it?
So for district,
Yes, district code is same, ADM2. But what I'm actually doing, it could be the mistake of spelling error.
yes, sir.
Okay, so I have seen all the state and the district name are written as the B. If the B become capital and I click run, to see my feature collection is showing one element and my data is showing the district boundary of Bhopal city. Okay, so if I mistakenly add this LL, it will not show my data set. So this is about the data set which is already ingested in the Google Earth Engine. But when you are working with a vector data, it is most required that you are going to use your own data set. So that is why the link which I provided you the Bundelkhand district boundary. Okay, so you just download this data set, and next thing we are going to. Okay, so before that, before using the district boundary, what I'm going to do, next task is to try to display another state and the whole India, or only 3 district or region. Like, okay, if I want to display maybe 2 state, like admin 1, Uttar Pradesh, comma, Madhya Pradesh. If I click run, it giving error. Why? Because it is saying that received too many arguments to a function equation and expected 2, but you got 3. When we analyze, it is asking only 2 arguments. One is the property name and another the property value. Okay, so what we have to do? Either we can combine this property value to only one argument by making a list. This is the one argument and this is the another. I just click run. No, it is not showing anything. Why? Because now we are asking the system to filter the data set which has the admin 1 name as both the values. But it cannot be possible. A single state cannot have the value of both Uttar Pradesh and Madhya Pradesh. So what we can do, we can use another filter like filter dot in list. Okay, so we will just search for filter dot in list, in which see you can get the 4 type of argument. It's left field, right value, right field, left value. Okay, so that means if I just use this e dot filter list and I'm using the left field, and in the right I'm giving the, see, if you see the right value is list or the object, that means you can provide a list also. So I just click run. And yes, I can visualize both of my state, that is Uttar Pradesh and Madhya Pradesh, both in a single layer. Okay.
Yes, sir.
Okay, sir.
Are you getting little bit of not or
Yes.
not?
Yes, sir.
Okay, so that is for the today, but there is a few tasks which you have to do by your own self, and we will discuss it about tomorrow. One exercise is this. You have to create in the document I've written, you have to create a median composite of Landsat of your own city. It can be Delhi, it can be Kolkata. If you, it can be any city you want to, and if you want to detect the changes of 2015 or 16 and 2020. So what you will going to do? You just first of all call this image collection of Landsat image. Okay, then you will apply the filter of 2015 and create a median. And the next thing you will do, you will combine the filter of 2020 and you will create another median, and you will display both the images with the visualization parameter. Okay, can you able to do by yourself?
I will try, sir.
Okay, and if you occurred any problem, then we will going to discuss this tomorrow, because if unless and until you won't do it by yourself, you won't get it. Because till now what is actually happening, I'm just telling you how to run a code and how to copy paste the code, but if the two things are important. One thing is you actually have to understand each and every line of the code, what is actually code is doing, then only you can understand what is actually happening behind the API. Second thing is you should be able to create your own script. You should be able to create your own code according to your own use. So you can do it by on your you can do it only when you're going to perform by your own hand. Okay. So this is the one task. And the next morning we are going to learn about how to import the data set which I provided you, and we are going to clip the data according to your own area. Okay, so this is another data set which I provided you, but we are going to discuss it about tomorrow. That is the reverse shape file. Okay. So any doubt from today's session? If yes, then we can talk about that, and if not, we can conclude the session. Or not only doubt, but any expectation from this training or any suggestion. I'm not even asking about the feedback, but asking about this suggestion a little bit so that we can improve in the coming days. Anyone?
No, not at all, sir.
Not at all. And you, Miss Davinia?
So no, sir, it's fine, sir.
Okay. So we will meet tomorrow at 2 sharp.
Yes, sir.
Thank you.
Thank you, sir.